And then we'll do the all right, so final exam. Just for flexibility, what I'm going to do is I'm going to put it up by Monday morning next week, and you'll have 2 hours to take it. You can take it anytime you want during the week, as long as you do it in a single sitting. So don't do it in shifts. It's going to put a timer on you as soon as you start it. It's you got to finish it in that time. What is the official time for when this class is supposed to have the final? Tuesday at 10. At 10? CUW final exam schedule. Resume my journey. 10:10 on Tuesday. All right, so Tuesday at 10 a.m. till noon, I'm guessing, is probably the window. Is the official time. So I will join Zoom during that time if you want to take it during the scheduled time and be able to ask questions, etc. Yada yada yada. I don't anticipate you having questions. I think it should be fairly self-explanatory. But if you want to make sure you have real-time access to me during the while you're taking the exam, I'll go on to Zoom at the exact time that you were supposed to take the exam, and you can just choose to take it then. If you want to come to the classroom to do it, that's fine, but you can do it wherever you want. It'll be up on Blackboard, just like the previous one was. So feel free to take advantage of that. Otherwise, you can decide when it fits best into your schedule for studying and all that jazz. I just need it in by 11:59 p.m. on Friday. So give me the weekend to get stuff graded. But that sound reasonable, everybody? Give you some flexibility during finals week, and if you don't want flexibility and you want to be able to clarify things during the exam. Otherwise, if you're taking the exam and you're unclear of what I'm asking about something, make a reasonable assumption and just tell me what you assumed so I can take that into consideration. I don't think that should be a major issue. All right. Otherwise, you can take at any time during the week and must complete in one sitting and submit by 11:59 p.m. on Friday. It is closed book, closed note, closed neighbor, closed internet, close. You can use a calculator. Or if you want to use your phone for doing math, that's fine. Just don't cheat. Right. That's the punchline. Don't cheat on it. If you were questioning whether or not what you're about to do is cheating, it probably is cheating. If you think it's reasonable to do it and you're not giving yourself an unfair advantage, then it's fine. Okay. So just like the midterm, 10 questions. All short answer. Essay. Programming. So no true false, no multiple choice, no fill in the blank with magical pick the right word out of the sky. So I don't know. Just like the midterm, I want you to prove to me your competence. So you know, I realize, and also I'll throw out there, for all the code stuff, I don't want you typing this in and testing it. If you want to use a text editor to type it in to get it formatted reasonably so you can paste it in, I'm fine with that. That's not a major deal. But I'm going to assume that you're giving me code that might have a couple of little bugs in it, a missing semicolon here and there, that kind of stuff. I'm not going to take off for that stuff. I want you to show me what you're able to do off the top of your head, not what you're able to debug within 2 hours. Make sense? I want to see what your competence is. So if you feel like you're having to hit the play button to test it, you're cheating. don't do that. Give me your best stab at it. But if you'd like to use a text editor for formatting, I'm fine with that. Again, you're all adults, you're smart. If it feels like cheating, don't do it. All right. So very, very similar to the midterm. It will be a cumulative exam. So it'll cover everything the midterm covered, plus the things we've done since the midterm. So I'll go through some of the slides since the midterm as well. Remember, my policy is that if you do better on the final exam than you did on the midterm, I'll replace the grade you got on the midterm exam with whatever you get on the final. So if you got a 15% on the midterm, which I don't remember what the lowest grade was, but it was something like that. It doesn't count if you didn't take it. You know? That's all I remember. Yeah, I think there were a couple people in like either the low 20s or high teens or whatever. Those people can still get A's in the class, right? Maybe it just didn't click yet for you. You had a bad week, or you forgot to study, or you were hungover, or whatever it was. Yeah, you know, look, you do you is the thing, but you know, you get a do-over on this one, but you know, at the end of the day, I have to give you a grade based on how well you've mastered the material. So don't get 220s in a row. Do better on the second one so I can replace your first one with that grade and give you a reasonable final grade in the class, so then I can torture you more in 250 is the deal. All right, questions about format or anything for the final exam? Like reasonable sense, sound fair and flexible and all that jazz. Remember, there will be at least one conversion question on there. So either convert from some base to another base, you know, maybe convert from binary to hexadecimal or something like that, or convert from decimal to octal. Or it could be convert from you know, gigabits to megabytes. So one of those two things. Those are things that I consider to be computer science core skill sets that I don't feel are covered adequately enough in our other classes. So you'll be bombarded with them in every single exam you ever have with me during your entire 4 years here. So if you have a Lippmann exam, there will be a conversion question on it of some type, regardless of whether it has anything to do with the class, because it has everything to do with computer science and the class is about computer science. So at least I have that connection. I doubt, though, let me think about this. There will be a maximum of 2 conversion questions on the exam. I'll probably shoot for 1, but if I need an extra question to kind of fit it into the right time frame, so you can, I kind of designed the exam to take about an hour. Or an hour and 15 minutes, something like that. I give you 2 hours, so I don't want there to be a time constraint on the exam. You know, if you want to take the whole 2 hours, you can, but you know, there's a chance that I might want to do 2 of those questions if I can't come up with another good other question or something, or I asked a question that maybe is a little bit longer to offset it, but there will be at least 1. All right, so let me just go back to since the midterm and let's talk. Oh, here, this lets us see what the deal was. Yeah, so oh, that was the missed one. So we had a couple people in the 30s. Yeah, so these folks, you know, can really repair their grade in the course by doing better in this final exam and having this erased. Otherwise, yeah, actually the class did okay. I mean, these are a little suspect here, but you know, in general, a majority of the groupings were really A's and B's, which is pretty good for this course, to be honest. That usually is not the case. Okay. So this was like me going over the examples from the midterm. We went over it. All right, so what we looked at after the midterm, things that were not on the midterm. I know we had talked about structs before the midterm. Structs would be a fair game on the final. Truth be told, I would probably say structs are not a high priority for me. So if I asked you a question about a struct, it would be because I've run out of other things to ask about. If I was asking about structs, I probably would just talk about classes because classes and objects are much higher priority to me. I'd say make sure you understand what a struct is in case I asked you a question about objects or classes as they relate to structs, kind of like maybe what's the difference between a class and a struct. Where classes give us the ability to also embed, constructors and methods, where structs can only hold name value pairs, something like that. But that's where structs might come in. Definitely understand the idea of pass by value versus pass by reference. We've spent quite a bit of time after the midterm talking about pointers, more about arrays. We looked at pointers to structs, we've looked at pointers to arrays, we've looked at pointers to objects. So there will definitely be a couple of questions on there that make sure you understand memory. So either passing around a pointer or dereferencing a pointer, know about the little arrow syntax, that guy. There won't be trick questions, but know about memory. That's going to be an important part. Keeping in mind that I'm also going to have programming questions like that were on the midterm that you're going to have to know about loops and if statements and all those things, and the kinds of questions I like asking on exams tend to be like either string manipulation questions or do something with an array. So like, I think you probably had a couple of these questions in the midterm. I've liked questions like, take a string in as a parameter and remove all the vowels or something like that, or count the spaces, or, things that have you show me in given the time format of a midterm that you have some algorithmic maturity, that I can give you a problem and you can give me a reasonable solution to the problem, even though the problem isn't necessarily a earth-shattering solution to something. I want to see that you're starting to think like a programmer. Okay. So, you can take it to the bank that you're going to have some programming questions. Definitely you'll have a question or two dealing, take a string in and do something to it. So be able to do string concatenation. So you're definitely going to, almost definitely, you're going to have a question that's going to ask you to take something in as a parameter and build up a string. That's going to be the result, right? I might have you take in an array and the size of the array and return the biggest value in their array, or the average value of the array, where you have to add them all up and divide it by the size of the array, that kind of thing. So little puzzle type of things that let you show me that you know what you're talking about. Things to pay attention to, and I mentioned this in the midterm, and I'll mention again now, and these are important things just from a reading the question perspective. If I ask you to write a function to do something, I'm not expecting you to show me a main method with a bunch of crap in it. I'm expecting you to give me a function that has a return type, a name, a list of parameters, and then I want the code written inside that function generically so that I could call that function with different inputs to it, and it would work for any of the inputs you give it. Okay, so if the question would say, write a function that does something, right off the bat, you should start saying, what's my return type? What do I want to name my function? What parameters do I need to take? I'm expecting, if I say write a function, I'm expecting you to write me a function. Makes sense? And it sounds funny, but those are super common mistakes with beginning programmers. You just think, because I might also say, write the necessary code to accomplish something. If that's the case, you could just write 3 or 4 lines of code, whatever it takes to do something. I think in the first exam I said, something like write the code necessary to display to the screen the numbers 1 to 100 or something like that. Then you could just write me a for loop and stuff like that. You don't have to worry about importing stuff or, anything like that. I'm really looking for your maturity in logic and creating algorithms and stuff. So if I just ask for some code to do something, you don't have to put it in a function. You could if you wanted to, but if I ask for a function, part of your grade on that question will be functions. Okay, being able to write the function with the correct return type and the correct parameters. Similarly to that, again, I nagged about this on the midterm. Make sure you understand the difference between writing a function that returns something and writing a function that displays something to the screen. Okay, so if I say write a function that takes in X, Y, and Z and does something to it, then displays the result to the screen, that function would be a void function. It's not going to return anything. And somewhere inside of there, you're going to be printing something out. If I say, write a function that takes some stuff in, yada, 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 and returns the sum of those numbers or whatever, now I'm expecting you to have a return type other than void for the function. And somewhere in there, you're going to be returning the answer. Okay, you will lose points if I asked you to return something and you printed it instead. It's a pretty simple concept. Pay attention to the difference. Okay. Again, super common mistakes from beginning and intermediate programmers that's why I drill that so hard. All right. These are just core concepts in programming and it's easy to overlook them. So make sure you pay attention to the question I'm asking. Okay. There will probably be at least one question on there where I give you like, here's some code. Tell me what it does. I'm not asking you to go line by line and say that this code, this defines an integer and sets it equal to 3. And this asks a question. I want you to look at the code as a whole, maybe give yourself a couple of example inputs to it and just see what the output is and tell me roughly what does this code accomplish? Okay, if you remember, I think on the midterm, there was code that effectively tested whether a number was prime or not. Okay, because what it did is it took a number in and it went through and checked all the numbers between 2 and that number minus 1 to see if any of them evenly divided by it, and it returned false. If none of them divided, if there was something other than the number in itself that divided it, or true if none of them did. Effectively was returning true if it was a prime number, false if it wasn't. Now, the ideal answer to that was this checks to see if a number is prime or not. But if you didn't remember the word prime or that didn't hit home, that's fine. You could just say, oh, this takes in a number and checks to see if any value between 2 and that number minus 1 evenly divides it and returns false if it does and true otherwise. Tell me what the code is accomplishing, even if you never come up with the word prime. You know, in that example, it's going to be worth all the points. It's, you know, I'm not asking you to connect it to some, you know, common solution or something from a math class that you had in your sophomore year in high school or something like that. The code is going to be self-explanatory. Tell me what it's doing as a whole. All right. So a lot of stuff with pointers. I don't like asking questions that really ask you to you should know that an integer is 32 bits and that a short is 16 bits and a char is 8 bits. Those are things you should know as a computer scientist, but I don't ask you questions about that. So you won't have to focus on how many bytes big is an int on the exam. That's not going to be something that if you didn't know or didn't recall during the exam, you'll lose points over. I very well might ask you to write some code that maybe allocates 50 bytes of memory and returns it as a I don't know, int pointer or something like that. So make you use the malloc keyword in some way to allocate some memory from the operating system. Certainly could ask you about arrays and kind of the nature of contiguous memory. Remember right next to each other because we can calculate which bucket. If I say bucket 5, it says start at the base address of the array and take, let's say it's an array of int, take 5 integer size steps through memory to get me there. That requires that all that memory lives right next to each other in memory. That is contiguous memory. Okay. Yeah, so I wouldn't ask you to like use this like size of thing or anything like that. I guess I throw out there it's fair game, but I wouldn't do that. I just don't see an example where that is something necessary, but certainly understand this slide on how, like when we say AR at bucket 3, start at the base address and take 3 integer size steps through memory to get you to memory address 112, which is where bucket 3 was. That's how arrays work. Okay. Okay, then we get into objects. So I would say the focus of this exam, the new stuff in this exam, the focus will probably be on objects. There will almost certainly be a question where I say something like, create for me a generic object for like a player. And let's say a player is keeping track of their first name, their last name, and their jersey number, something like that. Okay, write me a class with the correct fields, constructors, appropriate fields and constructors to represent that object. All right, so I'd expect you to write a class called player that has 3 fields, has a string first name, a string last name, and an int jersey number. And then you should have a constructor, also called player, that maybe takes in those 3 parameters and sets the fields equal to what was passed in. Show me that you know how to take an idea of saying, hey, I want to write some code that represents this thing I've described as a player, and you can turn it into that class blueprint for creating those. Okay. I might ask you to create some instances of that. You know, I might say, maybe create a display method inside of your player that displays their first name, followed by their last name, followed by their jersey number or something like that. So, and then after your class, I might say, create 2 instances of player and have each one display itself, something like that. So you should be able to show me the code to do that as well.
Something to do HTTP and CSC files.
No, I would probably just ask if you wanted to, you could. If you wanted to create a, you know, the header file for it, where you kind of say, this is what I'm about to do, and then the CPP file where so whatever you want is fine, because both of them are correct. But if you want to combine it into a single file, that's fine with me. Because again, I want your syntax to be good syntax, but I'm leaving wiggle room there for, you know, a hiccup here and there, because I really want to see that you have the competence to understand what I'm asking. If I say create an object to do something, create that object. If you were in Java, the same thing you're going to create in C++ that you might create a header file and a CPP file for is only going to be one file in Java. It's only going to be one file in C#. And you can make it one file in C++ if you wanted to. We've been separating it because I feel like that's better individual documentation. I don't know if you saw the link yesterday put on Slack. This came from Dr. Josh Locker. He put it in our faculty channel. Some site that releases, I think ZDNet, that releases the you know, kind of top programming languages each year, released this year's list, and C++ has actually moved up the list. So I think right now the most common programming language in industry is Python. That has more to do with, I would say that most people whose jobs are their programmers will not be writing in Python. Python's become so popular in industry because you have a lot of people who are doing part of their job is programming, and they're doing data science or something like that that's using Python libraries and stuff. So I think Python's number 1. Number 2, I think, was C. And again, why is C so high? We basically know C because the first half of the semester, before we had objects, we were writing C code. So procedural stuff. Why is C so common? It's common because all of our embedded systems, your washer, your dryer, all those things that have buttons all over it that do something, there's a little circuit board inside of that guy that gets programmed, and programming for embedded systems is almost always done in C. So number 1 and 2 on the list have everything to do with the number of jobs that exist on the planet and the number of appliances that exist on the planet. Okay. So then you get into the actual, hey, I'm a programmer languages. I think number 3 used to be Java for years and years and years. This year, C++ became number 3. Java is now 4, and C# is 5. And guess what languages you're going to be dealing with in your 4 years here? You're going to hit all 5 of those. So you're doing stuff that is very related to what you'll be doing in industry. And once again, Swift is way down the list because variables should not be emojis. So they had it coming. But in any case, very interesting. Unclear why C++ has moved up. Historically, C++ was kind of the language we used for creating operating systems and the language we used for creating video games. That's become less and less common as our other languages have gotten more powerful. My feeling maybe is there was a pretty major update to Unreal Engine this last year, which is the competitor to Unity. We use Unity here, so we're going to be introducing the Unity game engine in the 250 class. So we can go from this text-based stuff and start having crap dancing around on the screen and things like that. That'll be like the second 8 weeks, or maybe I'll start a little earlier than that. But we'll start with Java, then transition to C# in Unity. Unreal Engine is a competitor with Unity, and instead of C#, it uses C++ as its scripting language. And Unreal Engine had a pretty major update this last year that had a lot of game developers kind of shift maybe towards that a little bit. I'm sure this year or next year, Unity will steal that and up it by a little bit, so then you'll have a shift back, whatever. But I'm thinking at least part of that C++ movement was because of that. But in any case, not a joke language. So even though I've advertised in here that, oh, I'm picking C++ because it's this, older language and it scares you and shows you some of the details under the hood, it's still a fairly common language. But realistically, when you go and work in industry, you're probably going to be either writing Java or C#. So it's a pretty good bet. One of those two is what your job's going to involve. All right. So be able to use objects, be able to create an object, write a class that has the fields, the methods, and the constructors. Be able to create some instances. If I gave you an object, I say, here's an object, and here's what the constructor looks like. Go ahead and create 2 instances of this guy, something like that. Okay. Maybe I would show you a header file and say, create an instance of this and call one of its functions. For that, you don't have to know how the function's written. You just have to know how do you call it. And the header file gives you enough information for that. All right, know what a constructor is. That's the guy that kind of initializes your objects. Know that objects are pods that hold on to collections of 3 things: fields, constructors, methods. Okay. Objects can have more than one constructor. We haven't seen examples of that in here, so that won't be represented on the exam. But from your perspective, every object will have some number of fields. It will have exactly 1 constructor. Technically, you don't even need 1 constructor, but in your world, they have a 1 constructor, and they are allowed to have some number of methods. That's what an object is to you. So if I were to ask a question, as is possible that I would ask, if I say, what are the members of a class? Or what are the members that comprise a class? You would say fields, constructors, and methods. Those are the things that go inside of a class. And if we were looking at how that compares to structs, we would say, what does a struct contain? It only contains the kind of the field portion of that, just name value pairs, the variables. There's no constructors, no methods inside of structs. All right, so there's that. There's that slide, what I just said. Understand the new keyword. That's kind of our upgrade to malloc. I say upgrade. It's still doing the same thing malloc is doing. The new keyword requests memory from the operating system, just like malloc does. Malloc, though, requires us to say, this is how many bytes I want. The new keyword will figure out how many bytes you want, but the new keyword is always going to be followed by a call to the constructor for the object. Okay. Know what an instance is? So if I have a blueprint sitting here, that's a class, is the blueprint that tells me how to build some stuff. An instance of that class, an instance of that object is actual examples of things I have built with it. So the example I used in class probably is, I have a blueprint for how to build a certain house, and you go into a subdivision, some contractor has built 30 instances of that house in that whatever it's called, whatever. So that's what an instance is. It's an actual thing that was built from that blueprint. Subdivision. That's the word I was looking for. All right. Know what this arrow syntax is for? So it's equivalent. These two lines are equivalent to each other. So if I have a pointer, NC here is a pointer. So NC dot the first number is not going to work. I have to first dereference NC by putting the asterisk before it. That says, give me the value that lives at that memory address. And then tell that, we know it's an object that lives there, tell that guy to access one of his members. Or we can use the syntactic sugar built into C++, which uses the arrow instead of the dot. And this does the dereferencing and the calling all in one fell swoop. Saves you an asterisk and two parentheses. What you'll see in more modern languages, like when we look at Java next semester, is Java removes the special syntax for pointers. So a dot, it'll figure out what you meant by the dot. The arrow disappears. A dot is what you always use, and you'll never have asterisks floating around. But I promise you the same stuff is happening under the hood. All right, so know that arrow syntax, dealio. Understand this keyword. This is how an object refers to itself from within itself. Pretty much guaranteed that this keyword will be on the exam in one way or another. All right. And then, I won't ask questions specifically about our MUD or something like that. It's going to be more generalistic programming stuff. I might say, create a player object from our MUD where he has a name and a number of hit points or something like that for my example of creating an object, as opposed to a baseball team player or something that has a first name, a last name, and a jersey number, whatever. But I won't ask you specific stuff about our MUD and like how do exits work or anything like that. All right. Questions about the final exam? Go ahead.
So all this stuff plus stuff that could have been on.
Correct. But really consider that, I'm really going to focus on the stuff since the midterm in terms of concepts, but understand that we've still been exploring all those concepts in the context of, I still got to define variables. I still have to write if statements. I still have to write loops. Those things aren't going away. So I doubt very much I would focus too much on some very specific thing from the first half. The first half was really just introducing basic programming concepts that you're going to be using forever moving forward. But the core concepts I'm going to be asking about are going to be dealing with the things since the midterm. Other questions?
Is there like random number generation sort of stuff?
It's a good question. I would say yes, it's fair game. But I would probably be just fine with you just making just saying rand with a couple of parentheses after or something like that, and just say, oh, this gives me a random number in the format that I want it in. I'm trying to even think now. There's a decent chance I just wouldn't ask about that. I don't think you need to go and memorize third-party functions like that. If I wanted you to do something, maybe I would say, assume there exists a function called rand that returns a number between 0 and 2.1 billion. Use that to solve this next problem. I would give you that piece of information. So don't spend your time memorizing little things like that you would just do a quick Google search and say, oh, this is how I generate a random number. I'm not going to ask you about, what's the purpose of seeding a random number generator. It's interesting, it's important, but probably not something that gives me a ton of information about how much you've learned in the class. So keep in mind the purpose of an exam I wish all teachers looked at it this way, but the purpose of an exam is for me to test you to see how much you've learned about the things that are important that you learn. I already know all of you are pretty good at Googling, right? And I Google too, especially, I mean, in a given week, I'm programming in 5 different languages, and sometimes it's been 2 years since I used one of these languages or something like that. It might take me a week or 2 to kind of get some of the stuff, loaded back in there. So yeah, that's an important skill set, but we want to make sure you can do it yourself when you have to. Those are important things. But yeah, I don't anticipate asking you things that would require you during the exam to ask me for clarification. I certainly would if I put something on there about random number or whatever and didn't give you anything and you said, well, how do I generate a random number again? I would just tell you, or if you want, just make it up. I assumed there was a function called rand that returned a random number. But that only works for things like that. Don't say, I assume there was a function called question number 3 that solves that solves whatever you were asking me to do in question number 3. You might get a point just because I thought it was funny, but all right, other questions? All right. When in doubt, though, if you are clueless on some question, definitely write something funny. That is almost always worth a point if it's really funny. Sometimes it can be worth more than a point if it's super, super funny. if I have to take a break from grading because I'm laughing so hard, yeah, it's only going to benefit you. I'd rather you give me a good answer to the question, but in a pinch, something funny definitely breaks the monotony of grading. And I won't know it came from you unless I go back and look later, because when I grade exams, I have names turned off and I grade like all of question 1 at the same time, all of question 2 at the same time. So I have 25 question 1 answers next to each other and I'm grading them one after another. I don't know whose is whose. So every now and then a student will put something in there, right? I'm like, oh, that sounds like so-and-so, but and then I'll just take off all the points just to mess with you. All right, anything else? We're good for the exam? Everybody understand that the exam will be on Blackboard, available for you to start taking on Monday morning, and you can take it during any 2-hour block you want during the entire week, completely up to you. But I will make sure I'm live on Zoom at 10 a.m. on Tuesday if you choose to take the exam during the scheduled exam period, in case you feel better about having access to me if you want to ask questions or whatever. Make sense? So you still get to take the exam at the allotted time if you'd like, but I'm not requiring you to do that. So best of all worlds. Make sense? All right. So we good to now look at the final homework assignment? Anybody want me to go over any concepts or anything to clear things up for the exam? Nope. All right. And we can, what am I doing? Oh, this is my example I gave you for reading stuff in, right? We had already done that in class though, right? The reading stuff in.
I think it was mentioned, but never.
Okay, so it was good I did that. All right. Is this us? So inside of our dungeon thing, here you go. That is creating an instance of the room class. Yep. So this is me. Well, this is me describing what a room will be in the header file. This is me implementing this is the implementation of how to build a room in the CPP file. You could also combine these into a single file. But then later on, now that I've created my blueprints, which is done in the header and CPP file for room, now when I'm ready to actually use room objects, I can go in and room 0 is an instance of room. Room 1 is an instance of room. Room 5 is an instance of room. E0 is an instance of exit, so on and so forth. Those are what are instances. When I actually build that house using this blueprint, each of those houses I use, those are instances of this blueprint. Make sense? Good.
So what does it look like to make an object in just one file? would do this. My brain's just right.
No,
I
it's
always come
it's
to-
easy enough. You would take this. And you would do that with it.
Okay.
Not at the end of this, no. You would need the semicolon here. So you would just put your actual implementation in here, and then you would never have to come back out here and make the CPP and do that little syntax-y thing. That syntax is what glues those two files together.
Okay, then.
Yeah, so I mean, and when you do this in Java or C#, it's gonna look like this. Same thing for add player, you'll put the code underneath this guy. Yeah, it's the same exact crap. So I'm guessing that's probably the way you would have guessed it would work anyways. You know, just write the code in the header file instead of having it shown in one file and implemented in another one with that double colon glue syntax that you need to connect those two guys together. Other questions? Oh, go ahead.
Player.hp. And there's a room pointer currently. That's just creating memory addresses to store that.
Yeah, so these guys are the fields, right? So these are the variables that instances of player will keep track of. So a player instance will remember what their name is, and they'll also hold a pointer to the room that they're currently standing in. That's the intention of that. So if I'm a player and I only know two things. I know what my name is and I know what room I'm in. But I'm not holding on to the room in my head. I just know where to find the room in memory. That's what I'm holding on to. So this guy, this room pointer, current room, is our intention is this allows a player to know the room they're currently in. So for this assignment today, when a player leaves one room and enters another room, we need to make sure we update that dude so he becomes aware of the new room he's now standing in. When I leave this room and go into the hall, I need to update where I am in the world inside my head. Make sense? But keep in mind that there's a difference between when I wrote this was my intention of what I was going to use that for. But then you actually have to implement that with that in mind, right? You have two separate things there. So I intended to remember what room I'm in, but until I actually, because I think we wrote that initially, but we didn't use it until this last assignment. Really? Remember? I think we built our dungeon first, which didn't require a player to actually know what room they were in because we weren't utilizing it. But I think we still had that as one of our players' fields initially. So that was just kind of unused real estate with hey, it might make sense for a player to know their room at some point, but now we're actually using it as we're making our player move through the world. All right, other things? Is it a hard one? Am I gonna be able to solve it live in front of a class?
Yeah.
It's very embarrassing when I screw up.
You'll go. It's just so funny. Because it does, it works.
So really what he's doing here is he's setting me up. He's like,
Yeah.
by the way, don't trip.
If you find it before it happens, that'll be good.
I'm pretty smart sometimes. But I'm an empty husk. That was like 22. That's when I would say I was smart. 22, I was pretty sharp. Man, now I forget what day of the week it is. It's bad. All right. Speaking of which, what was the homework assignment? All right, write a necessary code to allow your player to walk around the map every time they enter a new room, yada, yada, yada. Okay, got it. Oy. I promise you, with the exam I write, I'll be able to pass that exam. Don't you hate that when teachers give you homework or an exam that you're like pretty sure they couldn't do? Oh my God, I always hated that in school. It's like, there's just no way Professor so-and-so could do this.
Another time, it's like, only the professor.
Well, that's at least that's like an unreasonable teacher, but at least partially acceptable. It's super frustrating when you're like, the teacher can't do this.
You ever had a teacher that like would take the test to do that?
I've never had that, although I always solve the test for the students in the next class. So But yeah, I've never had a teacher. I did have one teacher in grad school. Typically in the United States, a lot of the grad students in computer science are international students, and then some of it's an ethical thing, but a lot of it's a cultural thing too. There's a lot of cheating and stuff, and even in-person exams, they'll like look at each other's tests. I mean, it's pretty funny. I had a kid one time grab my exam from me during an exam.
What?
Yeah, just took it. And I'm sitting, and the teacher's sitting up there, and it was. But I had a teacher. He's the chair now at Western Illinois University, Dr. Dennis DeVolder, and he used to teach. He taught advanced computer architecture in the grad program. And what he would do is after like maybe the third or fourth student turned in the exam, he would just it was always a blank copy of the exam, but you didn't think that. You thought it was the copy the student just turned in. He'd stand up and just rip it in half and go throw it in the garbage. Keeps everybody on edge. All right, so let's look at what we're doing here in main. So in main, I define my player. I build my dungeon. What does my dungeon do? My dungeon builds a bunch of rooms. It remembers about the player. It defines a bunch of exits. Yeah, in the real life, what you would do here is you would probably store your information about your dungeon in like an external file, like in JSON format or something like that, and then you would read it in, and all this stuff would get generated behind the scenes from that. But we wanted to really focus on instances of objects and stuff here, so almost always when we do something the first time, we're not doing it in the best way. We're doing it in a way that is teaching you something. All right, so this glues all the stuff together, and then we tell the player to go ahead and look. All right, so really, this is the first time a player looks. We can make a decision where do we want to put the logic for a player to start playing. So maybe what I would do is something like this. I'll probably take that out of there, and then I'm going to come into player, and we're going to just write a function in player, maybe called play game, something like that. I'm kind of moving my game into player. So we'll call this guy play game. Where's my player? CPP. There we go. Ninja. All right. So void play game. Oh, and this is player. All right, and then whatever. So what I'll do here is the very first thing I'm going to say is I'll just say look. All right, so I'll tell the player to go ahead and look. So out here in main, we create our instance of player. We create our instance of our dungeon in terms of our player, and that builds all the rooms and stuff and throws the player into the starting room. And then I can go ahead and say the player play game. Okay. And at this point, our code should do the same thing that it did at the end of class last time. I've just moved a couple of the logic pieces around, because ultimately what I want to have play game do is have an infinite loop that just keeps asking the player, what do you want to do? What do you want to do? What do you want to do? And he'll move you into rooms and all that jazz. So let's test this guy real quick. Okay, so there is our modified setup, because I thought this made some sense. Sometimes you have to, as a programmer, you have to make the decision of which of my objects is in charge of what. There isn't really a right way of doing it. You know, we could have just written all the crap into our dungeon constructor. In fact, many cases I would say you don't want to have too much logic inside your constructors, because the job of a constructor is to construct an instance of the object. After it's built, then you can say, make stuff happen. Okay, so that's what I've done here. Right? The dungeon exists. The player's been magically put into the beginning of the dungeon. Now I'm going to go ahead and tell the player to start playing the game. All right, so inside of here, I'm going to just throw this inside of a infinite loop for the moment. with no escape. All right. So forever right now, if I run this right now, it's just going to keep looking over and over and over again. All right. So we want to put a little pause in there so the player gets to do something. So I'm going to do something like see out. We'll give him a a little prompt, something like that. And I'm going to go ahead and say string. Call this guy command. CN command like that. So we'll look. We're going to just give them a prompt, waiting for them to type something in. Presumably right now, all we're doing is moving around. So we're expecting them to type in something like north, south, east, west, something like that. This reads in that command, and then we want to operate off of that guy. For right now, I'm just going to do a see out on command just to make sure that I am reading this thing in. I just want to make sure everything's connecting. So I know I'm dealing with a string. So it should pop up now. It's asking me, here's my room I'm in. Obvious exits are west and east. So now I can type in east. It's not actually going to take me anywhere yet, but it's going to spit it back saying, okay, yeah, I read in east from you. Make sense? All right. Just real quick for testing, I'm going to go, oop,
Yeah, I really did.
infinite loops will do that to you. So just for testing here, one of the commands I want to support right now is look, so I can relook at the room I'm currently in. So I'll just ask a question here. If command is equal to look, then I'll go ahead and say this, look, tell the player to look again. All right. So if I run this dude again, I'm in the room now. I type in look, he just looks again. Spits the room information out in case I want to repeat. I missed what exits were there or something like that, which can happen in a actual MUD when you have multiple people coming and going in the rooms and things like that, because then your things might move up on the screen. You might lose track of the obvious exits. All right. Well, if they didn't enter look, they must have put in a direction, right? So else if, why don't we just assume it's a direction for right now? They entered a direction, so try to go there. All right. So now the room I'm currently in is called current room, right? So I'm going to say from a room's perspective, if I'm a player, I'm going to tell the room like, hey, I want to go to the east. So that's what the human typed in. We're not sure if there is a room to the east or anything yet. Okay. But that's what we're going to try to do. So what we're going to do is we're going to hand off to the room and we're going to say from a room's perspective, we're going to try to take an exit. All right. So we're going to go ahead and build into room. Void take exit string direction, something like that. So we will ask a room to try to take an exit. And presumably what he'll do to try to take an exit, he took in a direction. He's going to go through his array of exits, of which we have number of exits, number of those, and look for an exit with that direction associated with it. And if he finds it, then we'll take that. If we don't find it, it'll spit out saying no exit in that direction, or, like, where do you want to go? Whatever, something like that. So in room CPP, this guy, let's take it down there. This guy here. All right, so take exit. We want to go ahead and we want to go through all of our rooms. So for int I, all of our exits rather. For int I equals 0, I is less than this, is it number of exits? I plus plus. All right, so that's the number of exits we have in this room. And what we want to do is we want to go through each of those exits and find out if the direction, remember in an exit keeps track of the direction that exit is heading. So we want to find out, does the exit I'm currently looking at, does that guy's direction equal the direction I want to go? Okay, make sense? So we're going to say if the exits at bucket I, and then did I give us a way of, all right, I think I probably mentioned in class last time that once we talk about public-private protected, we would probably write a function called get direction from exit instead of being able to directly access the direction field here. But all these guys are public now. And for the sake of time, I'm just going to access it. So if that exit dot direction is equivalent to the direction I want to go, this means we found the exit we want. So now take the exit. All right. If we get to the end of this for loop here, that means we did not find the exit in that direction. So we'll do a little C out to the user. No exit found to the direction, something like that. So we'll just give some output back to the user, letting them know that there isn't an exit in that direction. Make some sense? All right. And we're going to test this logic here real quick. We're going to just pause this for a second because what are we doing in here? When a player tells the room they're currently in that I want to take an exit to the west, for example, that room's going to check all of its exits to find out if any of its exits have a direction matching west. If it does, then we need to put our magic in here. But if I say I want to take an exit to the elephant, for example, I'm not going to find elephant in there anywhere. So it's going to fail out of this for loop. And then we're going to say, look, buddy, I didn't find an exit in that direction. Maybe try again. Something like that. So what we will do here just to finish up this logic real quick, and then I'll come to you. So they entered a direction. What are we going to do? We're going to, from a player's perspective, they're going to ask their current room to take an exit. Is that what I called it? Take exit. Yep. Take exit in the direction of command. So a player will ask the room to take an exit. Which exit? The one in the direction that they entered. All right. And I can go ahead and test this guy. Oh, thank you. Thank you. Do it. All right. So I'll type in elephant, which is not west or east, right? So that's an exit that's not going to be found. I'll press enter. It tells me no exit found to the elephant. So then it's going to just spin back up in my player blah, blah, blah guy here. So I tried to take the room. It did whatever it did in here. It spun back up. The next thing I do is I look and I happen to find it in the same room, right? I'm sitting in the exact same room as I was in before. Question?
I think I just did all the logic in one place. That's all I bring to Kindle. But I think splitting it was, I could not figure out how to make it not print out that is not a valid direction. It would just say that is a valid direction, and then it would say that is not. It would just go to the else.
Okay.
So I think the partialization hoping that's something.
Yeah, and so what I like to do, and first of all, keep in mind, this is part of the learning process. Like I mentioned in class last time, I think it was you who brought it up. This was an assignment that was a pretty big jump. It's not really a jump in complexity because once you see the actual code we're writing, it's not hard code. There's just a lot of moving parts. There's files floating all over the place. So it's really forcing you to now think in a bigger world, a world that's much more like what programming in the real world is going to be like. So one thing that when I'm kind of visualizing, I think I mentioned it maybe when we first started talking about objects, and it's also how the Unity game engine views object-oriented programming, let's say. And that is, it's almost like we're watching a play. All right, so we're currently in the scene. The scene is that we have who's on stage. We have a player standing in the current room, and he sees some exits. Now, from there, you want to think about, well, and a player is one of the actors on the stage. The room is also an actor, I guess, who has the player in a big hug or something like that. Okay, but you want to think about if from a player's perspective, if a player says, you know what, I really want to go to the West. Who knows about the West? Well, the room has that collection of objects. So I'm going to say, room, can you please try to transport me to the West? I'm asking the room to do something on my behalf. That's why I wrote this code inside of room. It wasn't like this was right or wrong. That's kind of the logic path I go down where I think about who's in charge of those things. Because the other thing I could do is a player could say, well, room, give me all your exits and I'll check them myself.
Yeah.
You know, you could do that, right? There's nothing saying you can't do that. But if you want to kind of keep things as we put the exits inside of room for a reason, right? So if room is in control of exits, I'm just going to say, room, I'd like to go to the West. You figure that out for me. I'll throw the room the direction I want to go, and he will either take me there or yell at me and say, look, pal, there's not a direction. So I put you nowhere. I spit it out to you and say, look, I put you nowhere. There wasn't an exit there. And then what does the player do? The player is just going to go right back up through his loop. He hits the end of this while loop, spins back up, and he's going to look again. He says, well, I didn't get anywhere. That didn't work out. Let's try again. Make some sense? All right. So let me make sure this guy's still good. Yeah. Because it had told me to refresh. I didn't want to start writing some more code and have it be mad at me. All right. So that's only if we don't find the exit. But if we do find the direction that we want to go, this is the meat of the assignment right here, right? If I do find the direction I want to go, what needs to happen? Well, I need to remove myself from the current room, right? And I need to put myself into the next room. Now, remember that from an exit perspective. So I have, what have I found now? I have currently found the exit that I want to go through. What's an exit? An exit has a source room and a destination room. We are already in the source room. The only reason we even see this exit is because we're in the source room. Where does this exit lead for us? It leads to the destination room. So I'm going to go ahead and we're going to have a function inside of exit called take exit. All right, and we'll go ahead. We can actually say we don't actually have to pass the player that's going to take the exit here if we don't want to, because the exit could look in source room and grab the player out of source room and put him into destination room if we wanted him to. Okay, but I'm going to go ahead. Does this guy know about layer? So he needs to know about player here because I'm going to have a take exit function that's going to take the player in. So the way I'm writing it this way is I'm saying I found the, from a player's perspective, well, from a room's perspective, the room has found the exit that the player wants to take. So now we're going to ask that exit. Exit, the player would like to take this exit. Here is a pointer to the player. even though the exit could have gone and looked up the player from their source room. All right, so we'll go ahead and write take exit here. 4 minutes, we better expedite. Dun, 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 dun. I play a lot of Final Fantasy 14. I also played a lot of original Final Fantasy couple minutes ago. All right, so what we're going to do is we're going to go ahead and take this player and we're going to add them. And remember, a room already has a function for add player. And what does add player do for room? Add player sets that room's player and then updates that player's room to this new room. So it's already telling the player you've now entered a new room. Inside of exit here, take exit, we're going to go ahead and say this destination room, add player, the player. Who? Add player. All right, so when we take the exit, we're going to go ahead and add the player to that guy. And this was found inside of room. So when I found the room I wanted, found the exit rather, I'm going to go say this, the exits at bucket I, take exit, and I'll pass him, isn't it called current player in room? The player. So I'm going to tell the exit that I found to go ahead and take that exit with the current player. And once that exit's been taken, this function's over. That's it. I don't need to search for more exits. I found the exit. I told the exit to go ahead and have the player take the exit. The exit then took in that player and said, I'm going to go ahead and take this player. I'm going to put him into the destination room. The destination room is going to set its own, its current player to that player, and then let the player know that you're now in a new room. So then out here in player, go to exit. I already have the player from, actually, does exit have the player? It does not, so I'll actually need to say this source room and a room has a player. So it is the source room associated with this exit that has a player in it. That's the player we're going to be adding to the destination room. So we're, in this case, we're removing the player from the source room. We're putting them into the destination room. So then out here, that should be it, I think. That should. All right, so if I go to the west, now I'm in room 0. If I go to the north, now I'm in room 3. If I go to the south, I'm back in room 0. If I go to the east, I'm back in room 1. If I go to the east again, I'm back in room 2, blah, 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 blah. So I think that's the assignment. Perfect timing. Really?
Yeah, you did. Because you made a different function.
Oh.
I didn't end the for loop, and coincidentally, bucket 0 was east in one room, and bucket 1, the next one was east was in there as well. So you.
Oh. Yeah, that's actually a common problem, right? Yeah. No, I'm gonna sell it. So it'll be up on eBay. Yeah, I'll put a link to the. Well, yeah, there should be. Oh man, we could actually create a pyramid scheme. I'll sell it to the highest bidder, and then you can choose what you want to sell it for from there. All right. Well, if I don't see you in person before next semester, good luck on your finals, blah, blah, blah. Have safe travels. Don't stop programming over break. All that jazz. Feel free to practice programming, ask me questions, whatever. All right. Take care.
Yeah, question here. I kept getting an error running this, and this is a non-member function.
Oh, it's gonna be the thing without the double dots on it.
So like it happens throughout the whole.
Yeah, so this is inside a room. Yeah, so take exit, we're inside a room, you need to have the room. Colon there.
Oh, okay.
That's how we glue the two, that's how we associate the header file and this is the C++ file. Whenever you see that error, that's the problem.
So I just need to,
Make sure you,
okay, so if it shows up, that means I can make that base for all of them.
yeah, anytime you've written a function inside of the CPP class, you need to make sure you tell it that you're implementing it from the header file.
Okay.
And that's that freaky deaky, you know, whatever the class name is, colon.
And then also saying players in the player there.
Yeah. So we don't know about player in here, so you got to put class player.
You can just do it on the way and then have it.
Now he knows that there will, that's like prototyping.
Yeah.
Now he knows we'll have a class called player.
And then this is kind of just a general question, I guess, but so when, I'm just having, because this is everywhere, like, I'm just like, what is that referring to? Like, is that the exit that a player's in?
This guy, right? So we are currently inside a room. So this, in this case, is this particular instance of room. We're saying this room's collection of exits and the current exit, which is exit at bucket I, his direction.
Okay.
So this refers to the instance of whatever class we're currently in. In this case, we're in room, right?
Yeah.
Yeah, so we're in a room. So when I say this, I'm talking about this
Okay,
particular
so
room.
yeah, because I was just like visual.
Yeah, so I'm asking this room to take a look at his collection of exits, specifically exit at bucket I, and look at the direction associated with that exit.
Okay.
And then compare it to the direction I passed in.
Okay, so when like you change to a different room, this is now referring to that.
Correct.
Okay.
Yep. This is whatever room we're currently in.
Thank you.
Yep.